Good evening, my name is Dennis Chin, UR14CS319, and I am here to explain the fourth experiment of Unix Lab, which deals with base conversions using shell script. So let's go into our programs here. Okay, so our first program will be to convert decimal to binary, octal, and hexadecimal conversions. Okay, so first we enter a decimal number, and we are asked to input a decimal number, and then we input that number using the variable num. Then we print the following options for our switch cases: 1, 2, and 3 for decimal to binary, octal, and hexadecimal. Then, according to the user input, we move into our program here. So, say the input was given as decimal to binary. So first, we take the input number. Say we have given our input as 10. So while 10 is not equal to 0, we do remainder is equal to 10 modulus 2, which would give 0. Next, moving on, we have binary is equal to echo remainder $bin. So basically our remainder here from the previous expression is 0. So that would equate our bin value to 0. And then our next expression, number is equal to number divided by 2, would serve to divide the original number and break it down into smaller numbers till the number is equal to 0. So in this example, after our first stage is over, number will be set to 5. So then again, this loop continues. 5 modulus 2 would give you 1. Binary is equal to 1, and the previous value of bin, which was 0. So the current value of bin would be 1, 0, and number is equal to expression number is equal to number divided by 2. So then 5 divided by 2 would give us 2.5, which would just take 2 as example here. And this loop would further execute till we get number is equal to 0, in which case the loop will terminate. And at last we print the value of bin. The same logic follows for a decimal to octal and decimal to hexadecimal. In our second part, which is decimal to octal, we input the value, and the only change here from the first one to the second one is the value 8 here, since we're converting to octal. Everything else follows the same logic, likewise for hexadecimal. Now moving on to our second conversion, which is binary to decimal, octal, hexadecimal. First, we input a binary number. Again, we have a switch case here. We read the number and we have a switch case. So once we read that switch case, we indulge into our further conversions. So in the first case, we have binary to decimal, for which the logic is displayed here. So once we enter the number, which is not equal to 0, we move on to these expressions here. Remainder is equal to expression of number modulus 10. Then we create a temporary variable called temp. Temp is equal to $remainder, which is the output, the value we received into using the previous expression. And then we have the operator here, and $power, which was set to 1. Decimal is equal to expression decimal plus temporary, the values we've given before. and then POW is equal to expression POW times 2, and the number is equal to expression $number divided by 10, and thus that would give us our decimal equivalent of the binary input. To convert our next, move on to our next conversion, which is binary to octal, we perform binary to decimal first and then decimal to octal. So this logic here is performed first to convert our binary to decimal, and then the logic which was explained in the previous segment which is decimal to octal, binary, and hexadecimal is displayed here. So basically the program is divided into two, one where the binary is converted to our octal, and then octal to binary to decimal, and then decimal to octal. Yeah, so this logic follows for all the further programs, which includes binary to hexadecimal as well. And here is our output that I received. So I've given the binary number as this and gotten our decimal value equivalent, which is 39. Likewise for all the other two scenarios. Our algorithm 3 would be to get the octal number from the user. Our program is to convert octal to binary, decimal, and hexadecimal. So the logic is given here. First, we enter an octal number, read the number, and display the cases. So in our first case, which is octal to decimal, we give the power as 1. While the number is not equal to 0, we do the following here. Now, okay, so remainder is equal to $num modulus 10. Temporary variable is equal to $remainder. Power $POW. Decimal is equal to expression decimal plus $temp. Power is equal to expression power, and mod power 8. Number is equal to number divided by 10, and done. So this right here would convert our octal to decimal. And to convert octal to binary, we would use the logic we've just explained to first convert our octal to decimal, and then we convert the decimal to binary using the logic I've explained in the first part of our experiment. So the first part, as I mentioned earlier, is right here, and the second part, which is the decimal to recipient conversion, which in this case is decimal to binary, is right here. So that's that, and we do the same for octal to hexadecimal as well. So that's our program there. That's our input and our output here. So I've given 1, 2, 3, 4 as my octal number and received decimal equivalent of 668. Likewise, I've done the same for octal to binary and octal to hexadecimal. Moving on to our last phase, we have the program to convert hexadecimal to binary, decimal, and octal conversions. Okay, so our logic here, we enter the hexadecimal, we read the number, and let the user decide which conversion to take part in. So according to the user, we have given our switch cases, one which is hexadecimal to decimal, in which we print this first statement here, and then decimal is equal to echo, I base is equal to 16, number is equal to decimal is equal to 16 along with num. Excuse me. Yeah, so decimal is equal to echo. The IBase is equal to 16 because of our hexadecimal. And we have $num, the pipe command, which basically takes the input of our previous expression and sends it to BC. What is BC? BC stands for basic calculator, which a bench calculator, which can be used interactively or non-interactively with input through a pipe command. It's basically used commonly in where expressions are used, mathematical expressions are used in terms of arithmetic or something along those lines. And unless you print the value of decimal. The same logic goes for the rest. You take binary is equal to echo, I base is equal to 16, O base is equal to 2, the number, I and BC. And then you print the command, print the binary into our output screen. The same logic applies for the octal conversions. And our output is given as displayed here. Yeah, that concludes our experiment for base conversions. Thank you.